An intrinsically safe, often shortened to IS, device with an explosion protection level of I can be installed in a Division 2 area without a Xena barrier and connected to non-rated equipment installed in a safe area. This is acceptable because, firstly, an XI or IS device is designed to be intrinsically safe and does not require additional protection to be used in hazardous areas. Secondly, Division 2 areas are classified as less hazardous than Division 1 areas, and therefore, they do not require the same stringent level of protection. Thirdly, the connection between the XIOS device and the non-rated equipment located in a safe area does not introduce any additional hazards. However, installing an IS device that is different from what is specified could cause it to become unrated, even for Division 2 applications. This is critically important because IS devices are engineered and certified to operate within very specific parameters, which includes voltage, current, and power levels. Conversely, if an IS device is not rated for the specific application, it could lead to an unsafe condition. Secondly, using an IS device outside of its specified ratings could compromise its intrinsic safety design. For instance, if an IS device is rated for a maximum voltage of 24 volts, and it is installed in a circuit that operates at 30 volts, it could cause the device to overheat, malfunction, or even fail catastrophically. Thirdly, compliance with manufacturer's instructions is paramount when installing IS devices. Always adhere to the guidelines and specifications provided by the manufacturer. Fourthly, only use IS devices that are specifically rated for the intended application to ensure safety and proper functionality. Always select devices that are certified and suitable for the specific hazardous environment and application requirements. For further clarification, consider these points. Intrinsic safety, abbreviated IS a protection technique applied to electrical equipment and wiring for hazardous locations. The idea behind intrinsic safety is to limit the energy, both electrical and thermal, to a level below what is required to ignite a specific hazardous atmospheric mixture. Division 2 locations, as defined by the National Electrical Code (NEC) and other standards, are areas where ignitable concentrations of flammable gases, vapors, or liquids are present only under abnormal operating conditions. In contrast, Division 1 locations are areas where such ignitable concentrations are present under normal operating conditions. Xena barriers are passive devices that limit the voltage and current that can enter a hazardous area. They are often used in conjunction with IS devices to provide an additional layer of protection. However, if the IS device is certified for use in a Division 2 area without a Xena barrier, and the installation meets all other requirements, a Xena barrier is not necessary. Non-rated equipment refers to equipment that is not designed or certified for use in hazardous locations. This equipment must be located in a safe area where there is no risk of ignitable concentrations of flammable materials being present. Device ratings are the specified electrical and environmental limits for a device. These ratings are determined by testing and certification processes and are intended to ensure that the device operates safely and reliably within its intended application. The manufacturer's instructions provide detailed information on how to install, operate, and maintain the IS device. These instructions must be followed carefully to ensure that the device operates safely and effectively. Certification is the process by which an independent testing laboratory verifies that a device meets specific safety standards. IS devices must be certified by a recognized certification body such as Underwriters Laboratories UL or Factory Mutual FM. It is also important to consider the concept of entity approval. Entity approval allows the interconnection of IS devices and associated apparatus, even if they are not specifically certified as a system. However, entity approval requires a detailed analysis of the circuit parameters to ensure that the interconnected devices do not create an unsafe condition. When installing IS devices, it is essential to use appropriate wiring methods. The wiring must be properly shielded and grounded to prevent the introduction of extraneous energy into the hazardous area. The wiring must also be physically protected from damage. Regular inspection and maintenance are essential to ensure the continued safety of IS installations. The inspection should include a visual examination of the devices, wiring, and connections. Any damage or deterioration should be repaired promptly. Furthermore, consider the specific hazardous material that is present in the area. The IS device must be rated for the specific hazardous material to ensure that it will not ignite the material. The temperature rating of the IS device must also be appropriate for the ambient temperature of the hazardous area. The temperature rating indicates the maximum surface temperature of the device. If the surface temperature exceeds the ignition temperature of the hazardous material, it could cause an ignition. In summary, an XIRO-IS device can be installed in a Division 2 area without a Xena barrier if it is certified for that application and the installation meets all other requirements. However, it is crucial to use IS devices that are specifically rated for the intended application and to follow the manufacturer's instructions carefully. Installing an IS device that is not properly rated could compromise its intrinsic safety design and create an unsafe condition. Some further considerations include, firstly, proper grounding. Ensure all IS equipment and associated barriers are properly grounded according to manufacturer specifications and relevant safety standards like the National Electrical Code, specifically Article 504. Secondly, segregation of wiring. Run IS wiring separately from non-IS wiring to prevent accidental voltage or current induction into the IS circuits. Maintain physical separation as specified by code. Thirdly, use of approved components. Only use rated components, including cable glands, connectors, and junction boxes that are certified for use in the specific hazardous area. Fourthly, documentation. Maintain detailed documentation of all IS installations, including device ratings, wiring diagrams, and certification information. This documentation is crucial for inspections and maintenance. Fifthly, training. Ensure that all personnel involved in the installation, maintenance, and operation of IS equipment are properly trained in IS principles and best practices. Sixthly, periodic inspections. Conduct regular inspections of IS installations to verify that they are in compliance with safety standards and manufacturer recommendations. Document all inspection findings and corrective actions. Seventhly, control drawings. Use control drawings, which are detailed engineering drawings that specify the parameters and limitations of IS systems. These drawings help ensure that the system is installed and maintained correctly. Eighthly, understanding entity parameters. When connecting IS devices from different manufacturers, it's essential to understand and verify the entity parameters of each device. These parameters define the allowable voltage, current, and inductance and capacitance levels that can be safely interconnected. Ninthly, avoid modifications. Never modify IS equipment or wiring without consulting the manufacturer or a qualified IS expert. Modifications can compromise the intrinsic safety of the system. Tenthly, consider the ambient temperature. Ensure that the ambient temperature of the hazardous area is within the specified operating temperature range of the IS equipment. Excessive temperatures can affect the performance and safety of the equipment. Further details to note. Firstly, when selecting an IS device, verify that it is certified by a recognized certification body for the specific hazardous area classification, such as Class I, Division 2, Group A, B, C, or D. Secondly, ensure that these devices is properly installed and maintained according to the manufacturer's instructions and applicable codes and standards. Thirdly, regularly inspect these device and its associated wiring for any signs of damage or deterioration. Fourthly, replace any damaged or deteriorated components with IS rated components that are specifically designed for these device. Fifthly, never modify these device or its associated wiring in any way without consulting the manufacturer or a qualified IS expert. Sixthly, if the IS device is used in a Division 1 area, it must be protected by a Xena barrier or other suitable protection device. Seventhly, always follow the manufacturer's recommendations for the use of Xena barriers or other protection devices. Eighthly, ensure that the Xena barrier or other protection device is properly installed and maintained according to the manufacturer's instructions and applicable codes and standards. Ninthly, regularly inspect the Xena barrier or other protection device for any signs of damage or deterioration. 10thly, replace any damaged or deteriorated components with his rated components that are specifically designed for the Xeno barrier or other protection device. Also, consider these points. Firstly, documentation is key. Maintain accurate records of all his equipment, including model numbers, serial numbers, certification details, and installation dates. Secondly, training matters. Provide thorough training to all personnel who work with his equipment, covering proper installation, maintenance, and troubleshooting procedures. Thirdly, use appropriate tools. Utilize calibrated and certified tools when working on his circuits to ensure accurate measurements and prevent accidental damage. Fourthly, verify loop parameters. Before energizing on his loop, verify that all loop parameters, such as voltage, current, inductance, and capacitance, are within the allowable limits specified by the manufacturer. Fifthly, grounding practices. Implement proper grounding practices to minimize the risk of electrical noise and transients that could compromise the integrity of the system. Sixthly, cable selection. Select appropriate is-rated cables that meet the requirements of the specific application, including shielding, conductor size, and insulation material. Seventhly, sealing requirements. Follow proper sealing requirements to prevent the ingress of moisture and contaminants into its enclosures and connections. Eighthly, surge protection. Consider installing surge protection devices to protect his equipment from voltage spikes and surges that could damage sensitive components. Ninthly, alarm management. Implement effective alarm management strategies to promptly detect and respond to any abnormal conditions that could compromise the safety of his system. 10thly, emergency shutdown procedures. Develop and implement emergency shutdown procedures to quickly de-energize the system in the event of a hazardous condition. Furthermore, consider, firstly, the specific gas group. Ensure that the equipment is suitable for the specific gas group present in the hazardous area, such as Group A, B, C, or D. Secondly, temperature classification. Verify that the temperature classification of the equipment is appropriate for the maximum surface temperature that could be reached on default conditions. Thirdly, hazardous area boundaries. Clearly define the boundaries of the hazardous area to ensure that none of his equipment is located outside of the designated zone. Fourthly, intrinsic safety barriers. Use appropriate intrinsic safety barriers to limit the energy that can enter the hazardous area and prevent ignition. Fifthly, associated apparatus. Select associated apparatus, such as power supplies and control systems, that are compatible with these equipment and meet the applicable safety standards. Sixthly, control drawings. Utilize control drawings to document the design and configuration of this system, including wiring diagrams, component specifications, and safety parameters. Seventhly, installation practices. Follow proper installation practices to ensure that these equipment is installed correctly and in accordance with the manufacturer's instructions. Eighthly, maintenance procedures. Implement regular maintenance procedures to inspect and test these equipment, identify potential problems, and ensure that the system remains safe and reliable. Ninthly, competence assessment. Assess the competence of personnel who work with his equipment to ensure that they have the necessary knowledge, skills, and experience to perform their tasks safely and effectively. Tenthly, audit programs. Conduct periodic audits of the system to verify compliance with applicable safety standards and identify areas for improvement. In addition, take these actions. Firstly, verify certification. Before installing any equipment, verify that it is certified by a recognized certification body for the specific hazardous area classification and gas group. Secondly, inspect equipment. Inspect all its equipment before installation to ensure that it is free from damage and defect. Thirdly, use correct wiring methods. Use only approved wiring methods for his circuits, including shielded cables and intrinsically safe cable glands. Fourthly, maintain separation. Maintain physical separation between his circuits and non-his circuits to prevent accidental contact or interference. Fifthly, torque connections. Torque all electrical connections to the manufacturer's specifications to ensure a reliable and safe connection. Sixthly, document installations. Document all its installations, including wiring diagrams, component specifications, and certification details. 7th, train personnel. Train all personnel who work with this equipment on the proper installation, maintenance, and troubleshooting procedures. 8th, inspect regularly. Inspect its installations regularly to identify any signs of damage or deterioration. 9th, test periodically. Test its circuits periodically to verify that they are functioning correctly and within the specified safety parameters. 10th, follow procedures. Follow all applicable safety procedures and regulations when working with this equipment. Remember to also consider, firstly, the importance of proper grounding to minimize the risk of electrical noise and transients that could compromise the safety of the system. Secondly, the need to select appropriate is-rated cables that meet the requirements of the specific application, including shielding, conductor size, and insulation material. Thirdly, the adherence to proper sealing requirements to prevent the ingress of moisture and contaminants into its enclosures and connections. Fourthly, the consideration of installing surge protection devices to protect its equipment from voltage spikes and surges that could damage sensitive components. Fifthly, the implementation of effective alarm management strategies to promptly detect and respond to any abnormal conditions that could compromise the safety of the system. Sixthly, the development and implementation of emergency shutdown procedures to quickly de-energize the system in the event of a hazardous condition. Seventhly, ensuring that the equipment is suitable for the specific gas group present in the hazardous area, such as Group A, B, C, or D. Eighthly, verifying that the temperature classification of this equipment is appropriate for the maximum surface temperature that could be reached under fault conditions. Ninthly, clearly defining the boundaries of the hazardous area to ensure that none-is equipment is located outside of the designated zone. 10thly, utilizing appropriate intrinsic safety barriers to limit the energy that can enter the hazardous area and prevent ignition.